All right. This is the announcement for today's class. Quiz 2, we'll get to that soon, but the solution is released in the morning. The reason I didn't automatically release the solution is because the average in this quiz is 7 out of 10. So as opposed to last time, the average was around 9. This time it is 7. So I check which questions are really difficult. I found that one question, almost all of you got it wrong. So we'll get to that. That's why I didn't release the solution, because I want to see how I can change the quiz or change the grading process so that it doesn't account for the question that nearly all of you got it wrong. Midterms, this Wednesday to Friday. The reason I say Wednesday to Friday is because the midterms will be released on Wednesday. You can take that either on a Wednesday or you can take on any time before Friday noon. Okay. So the midterm question will be released on Wednesday noon, and there will be no class that day. The reason I didn't realize that the next day is actually holiday. Initially, I assumed that it's not a holiday. You can take the class, but I don't want you to work on a holiday. Okay. So what I'm going to do is I remove the class, in-person class. So that means you can spend that time to take the exams at 12 o'clock if you want to, until 2 p.m. is more than enough, but you have extra 1 hour to take the exam. If you don't want to do it, it's fine, but take any other time. But I'm not enforcing you to take the exam on holiday. I just don't want that to be a concern, because if you have any plan. But because we have to finish the syllabus, so I'm going to record the class anyway on Wednesday, whatever we don't finish. So take the exam either on that time or just watch the video of recorded exams. So I'll be online 12 to 2, like normal class. The recording is available. If you are taking the exam, you can ask me directly question during that time, because I'll be online. So treat it whichever way you want. Okay, just you have more flexibility in that way. The question will be released on Wednesday noon, right during the class. Assume that this is your class. Just nobody has to come here. Quiz. Again, I just want to mention that average was 7 out of 10. And the median is 7. Standard deviation is 1.6. The question that nearly all of you got it wrong is this question. Okay. So it says that Henry constant of oxygen in summer is different from that in winter. Is this statement true or false? Which is a tricky question in the sense it says Henry constant, but as you know, any thermodynamical constants always depends on temperature and pressure. The constant itself is not constant. It's just at same temperature and pressure, the Henry constant or Henry law constant is a constant. So that's the value is based on pressure and temperatures. So in summertime, the temperature is very different than in winter time. So because of that temperature dependency, the Henry law constant that you use in winter is not valid in summer. So obviously this is a the answer is true. But I'll check what answer it is done. But I have to check whether it's right. I have to check. I remember for some reason it says all got it wrong. So check your answers. But if it is everybody got it wrong, then obviously that's the question. I'll take it out. Oh, I see. That's my mistake. Okay, well, then it will be regraded. Okay, so I'll set it up. Okay, I just didn't. I was confused why everybody got it wrong. Okay, all right. So that's my apology. Okay, I made us. So actually, 93% got it right. Okay, I got it wrong. Okay. So when I was answer setting, by default, it says false. When I set the question, so maybe I didn't change that time. I thought I did it. So that's correct. So that's fine. Your average, this average will be wrong. Okay, so it will go to 8 point something. Okay, So I'll update it. Check the score later. I'm happy that it is most of you got it right, because I was really sad that one question that everybody got it wrong. I must have done really bad job. Okay, so a few things about midterms. I want to mention that that there is a midterms review uploaded on YouTube, which I had extra office hour on Friday. So I went through the midterm question last year midterm questions, and explained why the solution is the way it is. Okay, and if you have done your homework, all the homework solution, you have it. We uploaded it. If you understand the homework solution, you should be able to answer all the questions in midterms, at least the long questions. Short questions are conceptual, so it's your answers, even a wrong answer can give you partial credit as long as you explain your logic. So again, I want to iterate, do all the homeworks, okay, at least the long questions. I'll get to the homework solution shortly. There is a question on when you are going to receive the grade. And second thing is there will be 3 questions, 1 short questions, 10 short questions, and there are 2 long questions. Long question 1 is, I have not set up the question yet, so I can't really guarantee it, but at least I know these are 3 choices I have. 1 is mass balance, like a PFR, CSTR questions that you see in examples or last year questions. So that's 1 question. Second question is groundwater. That's one of the long questions. So if you know retardation factor, Darcy's law, you are estimating how long the contaminants will move, all that stuff. Okay, so that's the second possible long question. And third possible long question is a river problem, where dissolved oxygen is changing because of BOD discharge. How long before it will be reaching the critical point? So these are the 3 possible long questions. So as long as you know how to solve these 3 questions in homework, you got 2 questions right already. That's 70% of the midterms, because you have 2 long questions. Okay, and then short questions are pretty conceptual. You did the midterms or not midterms. You solve most of the questions in homework, which are not as part of long questions. There could be a short questions. For instance, even all homework you see, each homework question has many short questions. So those are also possible short questions in your midterms. So just go over through your own homework, the homework solution, we release it. If you understand them, you should be able to score more than 90% in the midterms, at least 90%. And I'll tell you the average in this midterms throughout the quarter. Everybody scored at least around 85, 87, that's the median, okay, 87%. The reason is it's very similar to homework. I don't test anything that I have not covered in the class. And also, I have the start. This was closed book before, and then we made it open book. It didn't really change the average. Okay, so I was expecting that open book will increase the average. Giving more time will increase the average to 90% or more. It didn't change much. Even though I didn't change the hardness of the question. So just know that this is the historical point. Every history is made by people like you. So everything you do this time is going to be part of future history. So don't go by that. All I am saying is, it's not, if you do your homework, all the homework question by yourself, you should be able to do well in the midterms. Okay. And this again, think of my motivation for this class is not to test you, have a hard question, all that. No, my goal is to somewhere motivate you to understand environmental issues and also how to solve it. So as long as you have exposure to all these different problems, you should be able to get your own information right when you have in future you work on any environmental problems. Okay, so that process, learning process, is what I really emphasize on. And introductory class are very hard. The reason is, imagine how many courses you have to take if you are environmental engineers for a master's or undergrad. Roughly 15 or 16 different courses we offer anytime. Imagine all those courses are compacted in this one course. So there are a lot of information. So it's really hard for many of you if you are first time seeing many of these. Okay, it might be very easy if you have taken some other courses. There are a lot of overlap. So that's why I understand that with a class with a very different group of students, it can be a range of expectations. Some might find it very easy, which expected, and some might find it very difficult. And it's the way the introductory class works. So do well, practice well. I'm sure you'll do very well in the midterms. Okay? And the question was when the homework solution will be released. This has been an issue even last year during pandemic. The reason is I don't grade the homework. I just give them a solutions. I give them some suggestion how to grade it. I ask them to read the solutions and give partial credit even though their answer is wrong. Try to find any way that you can receive some credits. And that every grader doesn't have the same logic process. So that means I rely on them to think like me. So to be honest, most of the graders are harder than me when it comes to grading, because they are students. They have, it's a binary world, so they feel like, this is not right, this is wrong, they feel that way. I look for where you get your thinking right, and I give a lot of partial credit. So what it means that whatever you receive in the homework, I want you guys to look at the solutions. If the grader takes some point off, it's not a reflective of how I think. So in the grade scope itself, you can suggest a regrade for any question that you think is not right. Okay, or you got it right, but the grader missed the point. So then when you do that, I grade those. Okay, so I go to that and I see whether the grader got it right. So one of the two things will happen. I may agree with the graders, and we increase your conversation with me, then we learn a little bit more. And if I feel like this is something you deservingly need points, I will immediately give you points. You don't need to even meet. So this is the case for most of the homework, and I officially cannot go for every question one by one. So that means I am holding on to some of them until I have the agreement with the graders. Okay, so that's why there is a delay, but I'll release it. Just know that if you don't get the points off, or if you have some points off, contact me through the grade scope, not email me. Just there is a button there, regrade request, for any question that you feel is not right. But your solution is there, right? So the solution I gave, you can always compare. Okay. Yes.
As far as we use the correct equation, like formulas, we should receive more than one.
Yes. So in midterms, as long as your approach is right, and you write the all units and all conversion formula correct, you get full credits, even you don't have the final answers. Okay. Homework too. Yes. I don't check the final answers directly in the midterms. I just see whether your approach is correct. You get full credit for right approach, right logic, and right units. Okay. Let's see here. There is a button. Okay. Let me see any questions that on chat window. Unfortunately, there is no extra credit for that things that I got it wrong. So for the Henry constant, that specifically you got it right, because I said the wrong answer in the quiz itself. There is no extra credit in the class, so if you miss by chance your quiz or your let's say homework, I can give extra, because that means I have to give for the entire class that opportunity. So that's kind of hard for a big class like that. But in short class, I do consider that for next year or next classes in spring and fall, not spring and winter, extra credit may be possible because it's a small class. In introductory class with 150 students, everything I do with one student, I make sure that it applies to everybody else. So there is no extra credit in this class. If you miss anything, it's gone. All right, so hardness questions. Last class we learned that how to actually calculate hardness. We have some examples. So the question looked like similar to this. Okay, I'll just go over through quickly so that you know what it's, because one question in the final is this question, so at least exactly look like that. So you'll be given some water quality information where you have concentration of calcium, magnesium, some positive ions, and calcium and magnesium are the ions that contribute to hardness. And then you have some anions. In this case, you have bicarbonate, SCO3, and sulfate, and chloride. Okay, so these are the places where the anions and cations interacts. And for your question, you will be calculating what is total hardness, what is carbonate hardness, what is non-carbonate hardness, what is alkalinity, what is a total dissolved solid, draw the ion concentration bar graph. So except E, all these questions can be in the finals. Okay. Now I'll tell you what is alkalinity. If you see the pH is near neutral. So alkalinity is same as SCO3. Okay. Okay. So this is 160 milligram per liter of SCO3. Okay. The unit is SCO3. And I'm just going backward. Okay. So, and what is total dissolved solid concentration? That's basically total dissolved solid, TDS, is concentration of calcium, all ions. Okay. Concentration of magnesium, concentration of sodium. You just add everything, all ions in the solutions. Now, when you add them together, one of the things that most students, at least some students, make mistake is just they add this 95 plus 25 plus 15 plus 160 plus 135 plus 73. That's wrong. Okay, the reason is the units are not same. It's 95 milligram of calcium, 26 milligram of magnesium. So you can't add milligram of something to another milligram of something else, apple to orange. So that means you have to change this unit to something that's same for everything. So one option is you can change to equivalent. How much equivalent per liter? Another thing which all the time you should use for any question in final is milligram per liter as calcium carbonate. So change all this unit, change all these units to milligram per liter as CaCO3. Okay. So once you change them, then everything else you can write, you can solve it. Okay. So that means total hardness, you know the formula is all the plus 2 and plus 3 ions. So calcium plus magnesium is total hardness. So all you have to do is add them together after changing them to milligram per liter as calcium carbonate. What is carbonate hardness? What is non-carbonate hardness? These things you can only answer when you draw this graph. Okay, because you have to account for how much of calcium, magnesium is associated with bicarbonate and how much them are associated with sulfate. So that's something you don't know just by looking at that. But I can guess once we solve this. So how do you change everything to milligram per liter calcium carbonate? So you use this table, something that's basically you already know how to do unit conversions. Molecular weights are already written, or elemental weight. Equivalent for mole for carbon dioxide is 2. Calcium, there are 2 charge, so 2. For magnesium, 2, there is 2 charge. For sodium, 1. For SCO3, that's 1 because 1 charge. For sulfate, there are 2 charge, so this is equivalent weight. And for chloride, 1 charge. Okay. The reason carbon dioxide is 2, last class we all cover it, but I just want to mention again. It's all about what charge it happens when it is inside water, not in atmosphere. So CO2 in water will produce H2CO3. That's carbonic acid. And that carbonic acid has, if you see what's the net positive or net negative charge in this, is a +2 or -2. So that's why carbon dioxide you have to account for 2 charge. So what is the gram for equivalent? So basically it's saying for equivalent how much molecular weight it has. So that will be, let's say this is column A, B, C, D. Then column E is basically column C divided by column D. So that's 44 divided by 2 is 22. This is 20. This is a 12.15. It's 23, 61. 96 divided by 2 is 48, 35.5. The next thing is, what is milligram per liter as calcium carbonate? The formula again, we have this long formula we wrote, but at the end this boiled down to this. This is 50 gram is basically molecular weight of CaCO3 divided by equivalent, which is 2. Molecular weight of calcium carbonate is 100, so that's why it becomes 100 divided by 2 is 50 gram. So all you have to do is just use this formula. So this one will be 22 times 50 divided by equivalent weight of A, which is in this case is 22. Oh, I'm sorry, this is the concentration here is for the carbon dioxide concentration is given 0. So this is 0 times this 0. For calcium, that's 95 milligram per liter times 50 divided by the equivalent weight is 20. So whatever that answer is. So this one will be the concentration for magnesium is 26. So 26 times 50 divided by 12.15. So basically what you're doing is this one, column F is concentration given in column B times 50 divided by column E. Okay. So write everything same way. So it's going to be 15 milligram per liter divided by 50 times by 23. This one will be 160 times 50 divided by 61. This is 135 milligram per liter times 50 divided by 48. Then this is 73 times. So this is milligram per liter. Once you do that one, you basically start drawing the graph. Okay. Just for sake of it, can anybody calculate 95 times 50 divided by 20? So that we can solve these questions. Once I know the number, then I can draw the graph. That's easier. Can anybody say 95 times 50 divided by 20? Or I can use my mobile phone as a calculator. Again, 237.5. Okay. The next one, magnesium. I need for magnesium, calcium, I need these 4. So those are the 4 things that contribute to hardness. So double charge. Okay. Other things are not important. It's not part of the calculations, but at least you should know that. So let's calculate those values first. 26 times 50 divided by 12.5. Sorry, I didn't. 106.99. So 107. There is a question if equivalent is calculated. Yes, because if you see I'm using column E, that's already accounting for equivalent. What about the SCO3? 131.1. What about sulfate? 146. Okay, thank you. All right, so next question is how to calculate. Let's write all these things. So again, I'm going to draw it because that's where you can calculate everything. Total hardness is basically calcium plus magnesium. So the answer for this is 237.5 plus 107. The answer is 344.5. Okay. Alkalinity, we just write 131.1. This is milligram per liter as CaCO3. Now the next two are important. How do you solve that one? So let's think of this way. I'm going to draw it, okay? That makes it a lot easier. So the axis will be, you know that maximum you want is 350, around 350. So let's say this is 100, 200, 300, 400. This is 350. So calcium, again, first draw calcium. This is roughly 237.5. So I'm going to draw calcium. Let's say this is my calcium, 237.5. So first draw calcium. So this is 200. That's 200. It's 250. So I'm just drawing a little bit less before than 250. So let's say this is my 237.5 marker. So that's your calcium. Then you draw magnesium. Okay, that's first calcium, then magnesium. So that's how they are attracted towards or reacted towards. So I'm going to let's see. I'm going to use these ions. Magnesium. You know, magnesium is around 107. So when you add this one, 107, it becomes 344.5. So let's say up to here. So I'm going to draw this one. Let's say this is, the marker is 344.5. So that's your magnesium. The next thing, what you do is you draw the negative ions and start with SCO3. That's how you do all the time. So SCO3 concentration is 131. So 131, so this is 100, this is 200, this is 150. So 131 roughly is going to be here. 131.1 marker. I'm just a eyeball. It's not really, doesn't have to be accurate when you do it. So let's say this is bicarbonate. So this is SCO3. The reason you can draw all in one scale because we change every scale into same unit. Okay, you can do that without that things. Then the next negative ions is sulfate, 140. So when you add 131 plus 140, you get how much? 271.7. That is SCO3 plus sulfate. So I have to draw out to 271.7. So let's say this is 300, this is 250, and I have to draw all the way 271.7. So that's roughly here. Let's say this is 271. So let's draw that. That's your sulfate. Then rest of the things you can draw, this is, you can say this is sodium, rest of them, and rest of them is chloride. Because every positive charge has to be accounted by a negative charge. So when you balance them together, it should be all same. Okay. But we don't need chloride and sodium because they don't really, at least we don't need sodium because that doesn't contribute to hardness. So now the next question is, what is the carbonate hardness? That means how much of the calcium and magnesium are associated with carbonate. So if you see in the figure itself, your calcium is the carbonate is up to here, right? So that means all the calcium, at least some of the calcium will be associated with carbonate, and then some of the calcium will not be associated with carbonate because they don't have enough carbonate. So in this case, your carbonate hardness is everything that carbonate we have. Okay. So that means this is your carbonate hardness. So this is all carbonate you have. Okay, and that is sufficient to have enough calcium associated with it. And what is total carbonate or total hardness? That's all calcium plus magnesium. What is non-carbonate hardness? Basically everything that's not associated with carbonate. So this is total hardness up to here. Then that means the rest of them is so another way to say is carbonate hardness is same as SCO3 is equal to 131.1. Okay. Non-carbonate hardness is total hardness minus carbonate hardness. Total hardness is roughly 344 minus carbonate hardness is 131.1. So you get 4, 3, 1. Okay. And if I ask you what are the different species you have, you will be able to calculate now. So basically up to here, all the species are CaHCO3. Okay, because you just basically overlap submerge on positive with negative. And then next up to here, you get calcium from top and bottom is sulfate. And then from here to here, you have some sulfate here. And then you have magnesium from the top. And then from here to here, you have magnesium as a positive and the bottom is chloride. Why this is important? Because how you remove those hardness is depends on how do you remove these molecules. Okay, and that's what we are going to learn about softening of water. Okay, and that's very important. Unless you know those numbers, you will not be able to answer the next question in hardness or softening. So up to here, you should be able to do all the time. You just arrange it, first calcium, then magnesium, first carbonate, then sulfate. Then you calculate all the value and then simply you will be able to estimate everything. Okay, that's 50% of your answers. Okay. Then second thing is softening. Softening means how do you remove this calcium, magnesium from water? Okay, and what's the chemical principle behind it? Any question? Again, you have to repeat this question many times. The homework that will release this week is based on these questions. So you'll repeat many times this type of questions so that you get practice. Again, this is one question in your final. Okay, that's no doubt about it. So you should repeat many times so that you can solve it. Again, you will have a solution too. Example solution when you do final. That's also open book. You just have to understand the concept. Any question? Yes. Multiple species? No. If it is the case, the reason is calcium is very attracted to carbonate. If there is calcium, enough calcium for every carbonate, they will not, magnesium cannot compete. Okay, at least in these equations, that's the assumption. Same thing, as you see over there, once calcium take off all carbonate, rest of the magnesium can be associated with sulfate. Okay, sodium cannot compete with sulfate as much as magnesium. That's why you order in that same way. Okay, there is assumption here. You put calcium first, then magnesium, then sodium, or any positive low charge. Same thing, start with bicarbonate, SCO3, then sulfate, or any -2 charge, then -1 charge. That's how they are attracted towards each other. Yes, you have a question? That's a good point. The only thing that changed when you do that, your alkalinity is not same as carbonate, bicarbonate. But in this class, you'll never get that question. The reason is all drinking water treatment system, the pH is between 5 to 8 or to 9. Within that, you can assume this is same. Because in nature, you never find that situations for the water treatment. Okay, so if you see softening process, this is the only thing that matters. All you are doing is removing calcium and magnesium. By what? Because magnesium and calcium is very strongly attracted to these ions. One is carbonate, CO3 2-. Magnesium is attracted towards hydroxide. So softening process is adding those ions. As long as you add those ions, you are removing those calcium and magnesium. So this reaction depicts the entire softening process. Okay. So all you are doing is conceptually calcium is precipitated as calcium carbonate, CaCO3. S means solid. But it means that it's precipitates. It means salts are being formed. So you can remove the salt as a sediment. They are no longer in water. And magnesium, OH. So the principle behind the softening is this. So now question engineering design is all about where do you get this carbonate? Where do you get this carbonate and where do you get OH? Where those come from? And the idea here is that you get carbonate by dissolving a lot of carbon dioxide in water, because carbon dioxide will become carbonic acid and that will produce CO3. That's the cheapest way because you have air everywhere, or carbon dioxide, that's easier to get. This one, you have choice of many choice. Sodium hydroxide, that's caustic soda. Another is lime. These are two options. One, you can see that when you add sodium hydroxide, you are adding hydroxide, you are going to precipitate magnesium out. In the other one, you put calcium hydroxide, that means you are adding another calcium, that's also source of hardness. But what it does, it also precipitates calcium out as carbonate if you have enough carbonate. So between those two choices, engineers, they choose this one, CaOH2, not this one. The reason is sodium hydroxide or caustic soda is very expensive. It's 10 times more than CaOH. So you can't afford to have sodium hydroxide in your system because it's just so expensive to use. And CaOH, they basically take lime. That's basically a white powder, okay, or white chunk, CaO, and add some water on it, and that produce that one. When you add water, or chalk. Some of the chalks are made of this CaO, lime. When you made this one, this produce CaOH2. So this is lime, this is lime slurry. The only reason people use CaOH is because even though based on the chemistry, it's not efficient if you use sodium hydroxide, because you are basically adding something to remove hardness without adding extra hardness. But there you add hardness along with removal of hardness. And any extra calcium you add because of this OH is going to precipitate magnesium, and the extra calcium will precipitate by these reactions. So that means you should have enough carbonate. When you are adding lime, you have to also add carbon dioxide. Okay, so that's the whole principle. So this is again, I said that this process is by adding those process. And as you can see, this is what in engineering, that's how they look. You have hard water coming as a groundwater, the very left side. Then you have adding lime slurry. That's basically calcium hydroxide. When you add calcium hydroxide, it's going to start making flux. So it will precipitate all magnesium out as magnesium hydroxide. Any calcium you add, that will also precipitate as calcium carbonate, assuming you have enough carbonate in your system. Because you are removing carbonate, you don't have enough carbonate for the next reaction to happen. That's why you are adding another carbon dioxide in the next system, because you deplete this carbonate in this reaction. That's why you have to add extra carbonate to precipitate any extra calcium in the next one. So you are adding more carbon dioxide. Another way to say this carbon dioxide is making a CO3 or CO3 2- based on the pH. And these are the ion needed to replace calcium. See these reactions? This reaction require carbonate. So by adding carbon dioxide, you are producing those at high pH. And CO3 is stable, or -2 is stable at very high pH. And the reason with high pH is because you add lime. Lime is OH that increases the pH very high. Once you finish that one, you'll see in the reaction, you remove most of the calcium, you remove most of the magnesium, but some of the magnesium could not be removed. That's why you have to add soda ash. Okay, soda ash is basically when you add soda ash, you are adding carbonate without adding any more hardness. Okay, and we'll get to that point. So when you add more carbonate, is basically you are precipitating calcium carbonate. Okay, so this is how the reaction works. Any water subtending process, this is the process that goes, and the principle behind is basically these reactions. Now I'll give you a bunch of equations, and I'll tell you how those equations are related to estimate how much lime is needed. Because in your question, you'll given a water quality problems with lots of hardness, and the question will ask how much lime is needed, how much soda ash is needed. Because these are the two questions you have to calculate. How much lime is needed based on how much hardness is there and what hardness species are there. And those you already calculate from the previous questions. And those lime requirement is basically equations. And that equation has many species. So those species are all you already calculate. As long as you know that equation, you just plug the value, you get the answers. So next 5 minutes, I'll show you those equations and where they come from. So this is the design goal. First, what they do is they add limes. That lime increase the pH. And when you increase the pH, it also consumes the carbonic acid. Any carbon dioxide is going to be removed. Okay, that's neutralize some of the carbon dioxide. And then you keep adding them so that you can precipitate these ions as calcium carbonate. Any OH is going to replace as magnesium hydroxide. So I already explained it, so I'm just going to put these equations. Now you can see how it works. When you add lime, first thing happens is carbon dioxide will react with this. Carbon dioxide will produce CaCO3. So if your question has carbon dioxide, this equation you'll use to see how much lime is needed. Okay, because lime, if you see lime is needed in these equations. So if you know this concentration, 1 mole of carbon dioxide require 1 mole of lime. 1 mole of CaSO3 require 1 mole of lime. 1 mole of magnesium SO3 require 2 moles of lime. So that means if you know this species concentration based on what you already solved, you can just calculate how much lime is needed. Okay, this is just the equations. And next, you know that to remove non-carbonate hardness, which is this calcium that coming from non-carbonate, it doesn't have any carbonate, you need soda ash, which is Na2CO3. So this is non-carbonate calcium, just to non-carbonate. This is also non. In the previous question, when I solved all this, non-carbonate calcium was CaSO4. Okay. In the previous question for magnesium, you know that non-carbonate magnesium was magnesium sulfate and magnesium chloride. Just an example. So that means this is basically this concentrations. Okay. So based on these equations, amount of lime, this is the lime requirement. This is the one question. This is the only question that you'll, how much lime is needed, how much bicarbonate needed. That formula based on this equation, you know that this is one lime, this is another lime, this is 2 mole of lime, this is another. So basically any concentration of carbonate, for 1 carbonate you need 1 mole of lime. This equation is done. For 1 carbonate of CaCO3, you need 1 moles of lime. So this equation is done. For third equation, you know that for every magnesium SCO3, you need 2 moles of lime. Okay, so that means you have 2 times the concentration of magnesium SCO3. Then the lime comes from this equation. So this is non-carbonate hardness, non-carbonate magnesium. Okay, because this is carbonate, this magnesium is a source is carbonate magnesium. Same thing if I ask you what is the concentration of Na2CO3, that you know that Na2CO3 is only these 2 equations. So that means every concentration of calcium from non-carbonate source is for 1 mole of that, you need 1 mole of sodium carbonate. Same thing, 1 mole of magnesium. So these are non-carbonate hardness. And this species in this if you are writing this question, this will be calcium sulfate plus magnesium sulfate plus magnesium chloride. And those concentration you already calculated in your question. Okay, so all you have to do is just plug the value and then you get the answers. So again, this takes a lot because there are a lot of chemical equation. It takes time to understand it, but at least you should know conceptually where they come from. I don't expect you to write all these equations. If I ask what is the total lime requirement, you just write these equations. Okay, and these each species you already calculate from your graph, plug the value, you get the answers. That will tell you how much concentrations. Okay. What you got is amount of concentration of lime. How do you calculate total amount of lime? So total amount of lime is basically concentration times the volume of water being treated. So this is milligram per liter concentrations times volume of water, millions of gallon of water, whatever the volume, you just multiply. So that's the answers. So how do I get this each reactions? Because if you see, I wrote these reactions. This reaction is because of many small reactions. Each element break into small spaces, and then finally this happens. So you don't need to look at those. I want to put it there so that you know how the actual reaction happens. It doesn't happen that calcium hydroxide immediately find carbon dioxide. Calcium hydroxide goes through certain process to break into calcium, break into hydroxide, then carbon dioxide. When it dissolve in water, it form different species. Then each species interact with each other. So that's what it happens. Okay. So same thing for each equation. I just put it here. You don't need to really know these answers, but just know that conceptually how I wrote these equations. Bottom line is this equation. This is all you have to know. Calcium hydroxide is total amount is this. Okay. This is again non-carbonate hardness source. Then this one is both are non-carbonate hardness. So this calcium or magnesium depends on what species. I just wrote as +2. It could be calcium sulfate, calcium chloride, magnesium sulfate, or magnesium chloride, based on that particular questions. So estimate the concentration. That's what using this equation. Convert that to whatever concentration needed, and then multiply volume. Because this concentration what you found is milligram per liter as calcium carbonate. I ask what is the total amount of lime or soda ash. So first you have to change concentration of calcium carbonate to concentration as soda ash. All right, so that's all the equations, and we are going to solve one question after the break. That way you know how to do it. Okay. So 12:58. Let's meet at 1:10. Okay. And we'll solve it so you see how the process takes place. Put the microphone on. That's right. Sorry about that. Okay. So this is a question on finals in 2018. These are the constituent given to you. Okay. pH is 7.2. All that means is because pH is near 7, you can say that SCO3 concentration is same as alkalinity. And all the species are associated with SCO3, not carbonate. Okay, that's all it means. You are in charge of operation of a facility to treat 10 million gallons of water per day. Okay, so the flow rate amount of water that you need to treat is 10 mgd. Then you can convert that to basically 10 million is 10 to 6 gallon per day. So gallon per day, you can change per liter. That way you can calculate everything. So this is gallon per day. And then you can 1 gallon is 3.75 or 785 or something. Just check what's the unit. 1 gallon is 3785 probably liter. Then you get the basically liter per day. Assume that extra lime, 30 milligram per liter as calcium carbonate, needs to be added to raise the pH to precipitate magnesium hydroxide. So what they're saying is you have to add extra lime, 30 milligram per liter, in addition to all the treatments that you have to do based on the equation. So that means in that equations, for lime requirement, you have to add another 30 milligram per liter. Okay, that's all it says. Then the first question was estimate the concentration of carbon dioxide, all these things as milligram per liter as calcium carbonate. So that's your questions. Okay, so that's the bit one, that's the 2 points. So all you have to do is just use the table. I already did it during break, so I don't have to calculate. So that's the reason it's there. Okay, so that's 2 points. Okay, the next question was calculate the carbonate non-carbonate hardness of water as milligram per liter as calcium carbonate. Okay, so total hardness is calcium per magnesium. So if you write the answers, calcium is 300, magnesium is 251, calcium is 200, magnesium is 251, 451 milligram per liter as CaCO3. All these things, formula I told you that if this is the case, you can do this versus that. It doesn't really matter. If you draw it, you'll see why it is the case. So let's go to the point, start drawing it. Okay, so I'm going to start drawing. And you know that the total scale is around 451 length long. Okay, because that's the total hardness. So I'm going to draw that one. So this is 100, 200, 300. Oh, I did it wrong. I don't have enough space now. So 100, 200, 3, 4, 5. So this is 500. Okay, so it's 100 marker. And calcium plus magnesium is 451. So 451 would be, this is 400, this is 451. Okay, so let's start drawing it. First is calcium. Calcium is 200, so I'm just going to draw 200. So this is up to here. It's 200 mark. Then you add another 251 to become 451. That's magnesium. So I'm just going to draw that. Let's say this is magnesium. This is here. This is magnesium. Okay. So this one is 451 marker. Just 250. Next you have to do is a SCO3. SCO3, you know, the concentration is 350. So 350 is roughly here. This is 3, this is 350. 350 marker. So SCO3 is rough 350. So I'm going to draw 350. Let's say this is SCO3. Okay. Then next ions is sulfate, which is a 200. So 350 plus 200 is going to be 550. So this is 600. This is 550 roughly. I want to draw that. So this is. So now you may say, you know, what are the rest of the things? You can see they have given sodium, which is 100. So if you add 450 plus 100 is 550. So this is a, I mean, I don't need to draw this one, but because sodium is not needed for many of the calculations, but I'm going to draw it so that you can see, say sodium. Just so that you know what is the sodium. Then you have chloride. Sodium is roughly 100. So 451 plus 100, 551. And then 350 plus 200, 550. And then you have 100 for chloride. So you have also 100 for chloride. You don't need it, but this is basically chloride. That means there are other ions present. So now first thing you have to do is draw total hardness. So this is again, calcium for magnesium is total hardness. If I ask you what is the bicarbonate hardness or what is the carbonate hardness, is basically, you can see some of the calcium will become SCO3 for calcium, and then some rest of the carbonate will go to magnesium. So total carbonate hardness is because whatever carbonate present, they are associated with either calcium or magnesium. That means entire carbonate you can say as carbonate hardness, or it's not total carbonate hardness, we can call just CH, carbonate hardness. Then total minus carbonate hardness is become, this is NCH, non-carbonate hardness, rest of them. Now if you write all the spaces, because that's what you need for your equations for lime requirement, you have to write this way. So let's start writing those. For calcium, so I'm going to start drawing all the intersections. So there is intersection here, there is intersection here, so everything spaces count. So let's, this one, from here to here, you'll get SCO3. From here to here, you get magnesium SCO3. Because you just overlap both positive and negative. From here to here, you have positive as magnesium, negative as sulfate. From here to here, you get sodium sulfate. You can write that, but it doesn't matter because sodium is not part of hardness calculation, so you don't need to write that. So that means all spaces that you have to account for is those three. So if you write this equation, CaS3O3 concentration is basically up to here, 200 milligram per liter as. And this one value would be up to here 350 minus 200. So that's 150. Because up to here is 350, up to here is 200. So you subtract that. And magnesium sulfate is basically up all the way 451 minus whatever that marker, 351. So 451 minus 350 is 101. I'm just going to write it here again. How I got 150 is basically the line would be here 350 line minus the 200 lines. So once you know this species concentration, now you can calculate the lime requirement. Okay. So this is all the species associated with calcium or magnesium. That's all you are looking for in this paragraph. Now you have this one, then let's calculate the lime requirement. So if you start writing this one, carbon dioxide concentrations, what's the number? 50. CaSCO3, from here you calculate 200. Magnesium SCO3, 150. Then magnesium non-carbonate hardness. Okay. So what are the magnesium that is not related to carbonate hardness, which is magnesium sulfate here. Okay. Because if you see, one magnesium sulfate is same as one magnesium plus one sulfate. So it's one equivalent. So that means you can convert the same way. Okay. So that is basically 101. If you calculate that, that's 150 times 2, 300 plus 200. So 550 plus 106, 151. Okay. as CaCO3. So amount of lime required is 651 milligram per liter as calcium carbonate. So estimate the lime concentration as CaCO3. The answer is 651 milligram per liter. Then I ask, convert that to milligram per liter as lime. Okay. So lime is CaO. So all you have to do is you have to see how they are equivalent related to each other. So I'm going to write it here, 651 milligram per liter CaCO3. What is the molecular weight of calcium carbonate? One calcium carbonate molecular weight is 100 milligram or 100 gram CaCO3 is 1 mole CaCO3. Is basically we are changing one unit to another. That's the same thing going on. 1 mole CaCO3 is same as 2 equivalent CaCO3 because each calcium carbonate can produce 2 ions, right? One equivalent of anything is another equivalent of anything, right? So that's one equivalent of CaO. Then you know that calcium hydroxide, calcium oxide, when it has calcium, so it can also produce 2 charge. When CaO add with water, it produce CaOH2. That's something I wrote already. So that's Ca2 plus 2H minus. So this N equal to 2 because 2 plus charge for CaO. So 2 equivalent of calcium oxide is or lime is same as 1 mole of lime. Then 1 mole of lime is same as molecular weight of lime is calcium is 40, oxygen is 16. So that's 56 gram of lime. That's it. So then everything cancel out. You'll be able to get the answer in milligram per liter. So ultimately what you are doing is milligram per liter as lime as CaCO3 times molecular weight of CaCO3 times molecular weight of lime. That's the answer. Milligram per liter as lime. Because both are same equivalent, that's why you can write that. So when you write these equations, you'll get 651. Can somebody calculate 651 times 56 divided by 100? (651) times 100 times 56 divided by 100. Everything cancel out. 364. Okay. So then total lime requirement is 364 milligram of lime per liter. And the volume of water that you treat per day is 10 million gallon per day. So that's whatever that answer is. 10 times 10 to the 6 times 3.785. So 10 times 3.78 is 37.85. So I'm just going to write that value here. 37.85 10 to the 6 liter. So the answer will be in milligram. And you can change that to kilogram by changing milligram to kilogram. So as you see, all you need is a concentration for all those things. And one thing I missed here, it says that you need extra 30 milligram per liter as CaCO3. So I didn't account for that one there. So if you do that one, extra lime extra lime, so you have to add here. I'm just going to write in a different color, plus 30 milligram per liter. Because that's something is written there, that extra that you have to add. But if I didn't write that one, you would solve exactly like this. So that 30 is extra all the time because that question says so, that this is something usually done in practice. Then everything will change just based on that number. So next question, calculate the amount of kilogram of soda ash. So that means you have to actually change to be kilogram. Soda ash required per day. So again, so you have to look for, these are all non-carbonate hardness. So any calcium that associated with non-carbonate hardness is going to be in these equations. So if you see how much non-carbonate hardness of calcium in this equation, you see over here, all calcium are associated with carbonate. There is no calcium left to actually use for sulfate. So that means non-carbonate hardness for calcium is 0. Okay, because there is no calcium species that are not associated with carbonate. So this value is 0. For magnesium, all I'm asking is which magnesium species that are not associated with carbonate. As you can see, there are two magnesium species. One is magnesium bicarbonate, another is magnesium sulfate. All I'm saying is this one. So that's equal to magnesium sulfate, which is 101. This is 101. Estimate the, I think it says soda ash concentrations. Soda ash concentration is basically given on top, is as CaCO3. Convert that to milligram per liter as soda ash. It's the same thing. Soda ash has the 2 equivalent charge. Calcium carbonate has the 2 equivalent charge, so it's a ratio of molecular weight. So you can just directly write that one. 101 milligram per liter as CaCO3 times molecular weight of CaCO3 times molecular weight of soda ash. 101 times, this is a 100 gram per mole. This will be molecular weight of soda ash. So sodium is 23 times 2. So it's a 23 times 2 plus carbon is 12 plus oxygen is 16. So that would be how much? 60 plus 46. So I think 106. So 101 times 106 divided by 100. Roughly it will be something around the same range. So that's going to be okay. And to CO3. Total soda ash. Again, same thing, 37.85. That's the volume. 6 liter times concentration is what's the number? 101 times 106 divided by 100. Sorry, you have the calculator, so I'm just looking at you. How much? 107. 107.6. 06. Okay, that's one. Thanks, Adam. All right, so milligram per liter. Then you have to change to 10 to the 6 milligram is same as 1 kilogram because we asked what is in kilogram. So basically that will be cancel 37.85 times 107, whatever that answer is in kilogram. The next question is calculate the amount of CaCO3 precipitated per day. Means how much sludge you have to account for, because they are all precipitating, right? So again, that equation is this. Okay, this is non-carbonate hardness. That's something in the, I probably skip through the equations. Basically here. Amount of solid produced is amount of magnesium hydroxide precipitate plus amount of calcium carbonate precipitate. Amount of calcium carbonate precipitate is all the equations. Amount of magnesium hydroxide is this equations. Okay. So when you add them together, you'll get the whole thing. So this question is here. So again, this is non-carbonate hardness, non-carbonate hardness, non-carbonate hardness. So when you write these equations, that's why I wrote these equations. Okay, that's come from there. Okay, basically same equation. 1 carbon dioxide precipitate 1 mole of calcium carbonate. 1 mole of calcium bicarbonate precipitate 2 moles of calcium carbonate. If you see that equations, if you see original equations, all we are calculating is this, how much calcium carbonate is produced. So as you see, for 1 mole of this, you produce 2 mole of calcium carbonate, you precipitate 2. So that's how we are just writing that equations. So you put that value, so start writing that. Carbon dioxide is how much 50. This is 50 plus 2 times CaCO3 is 200. 2 times magnesium SCO3. Magnesium SCO3 from here is 150. Non-carbonate hardness for calcium is 0 because there is no calcium species associated with sulfate. And then magnesium that associated with non-carbonate hardness is sulfate, which is 101. So whatever that answer is, 200 times 2 is 400 plus 300, 700, 750 plus 81 milligram per liter as CaCO3. So that's 851 milligram as CaCO3. And it says what is the total amount of solid produced as calcium carbonate. So same thing, volume time concentration. So that's 38.78 or 38. What is that on volume? 37.85 liter times concentrations. Then you change to kilogram. So that means 10 to the 6 milligram is same as 1 kilogram. Okay, so again, this is one question in your final, and all I want to say is that everything depends on your ability to do this graph. Okay, if you can get this right, everything else is going to be affected. But in final, if you get one thing wrong here, you lose some point, but that doesn't carry over for the next question. So any mistake happen in one bit, if that question relate to other question, that question error associated with that will not deduct any point. Okay. So try doing this question as many times, or this type of question in homework. That way you are at least secure for one final question that you can do it anytime. Okay. So this is another example question that I want you guys to do it. And this is also in the textbook, right? So the solution is accessible to you. All right, so we are not going to teach wastewater treatment from now on, in the sense that today I think we have enough. Okay. Just to solve that question, it took the entire class, and it was worth it because I know this is your 1/4 of your finals. Okay. So learn it and you know how it is done. So I hope that, and also your next homework, which will be released on Wednesday, which will be due on next Wednesday, which is just these questions, many questions, same repeated questions. So you will have at least practice for 2 or 3 questions in homework, and you just repeat many times. So it's not difficult for the homework, next homework. Next class, again, I want to say that we are going to have next class on recording. So I don't expect you to, you should take the exam same time as class if you want to, but if you don't take, it's fine. But I'm going to upload the recording at 12 o'clock as well as the exam. I know that one of the students is traveling. So if you are traveling and you want to take the exam before the time, let me know. We can arrange that just for you. Okay. But throughout the entire class, I expect that all of you take exam from noon on Wednesday and you submit by Friday noon. But once you open the exam, it will be 3 hours. Okay. So just because you have 3 days doesn't mean that or 2 days, you don't open the exam and finish the exam end of 2 days, because it will count the time counted once you open it. So make sure that. All right, so take the exam, make sure that you write everything. Don't leave anything blank, because that's where I can give more points. And good luck for the exams. There are some questions. Okay, I don't see any questions.